Hello friends, you may recall last time we discussed various emission inventory models, and today we will apply two of those models like IVE model and VAPI model, how to use them to get different scenarios so that policy related or technology related impacts can be analyzed by application of these models. So, the real life application of these models would be discussed in terms of case studies. 4 case studies we have included in this particular presentation. First case study is based on IVE model, that is International Vehicle Emissions Model of USA, and 3 case studies will be related to Vehicular Air Pollution Inventory Model, that is VAPI model, which was developed by IIT Roorkee. Okay, so these are the case studies basically. One IVE model was applied in Pune to estimate emissions and their patterns, and then like impact of altitudes on different kind of vehicle category, on emissions of different criteria pollutants, and estimation of exhaust and non-exhaust emissions of pollutants from vehicular emissions or transportation related emissions. And the last fourth study is related to again impact of altitude on the rates of emission rates of precursors of ozone. Okay. So, these will be discussed, and then later on we will discuss the limitations of IVE and VAPI model. You may recall last time also we discussed certain limitations of IVE model, and then we will conclude this presentation. So, the case study first is related to application of IVE model in Pune, India. Okay. This was the study which was conducted in 2003, and later on the results were published in 2007. So, this was applied in this particular city of Pune of the Maharashtra state of India, and different kind of data were collected based on like video taping or measurement of traffic counts and patterns of their movements, and then tracking their representative vehicles with this GPS system. Okay. And then monitoring like start and startup and braking related patterns, and conducting on field surveys so that the real life data could be included in the study. That was very important, not only the secondary data, but the first set of the data, primary data were also estimated or collected by virtue of survey. So, the study area of the Pune is shown, and you can see there were 9 sample roadways where this survey and monitoring were conducted and vehicular movements were analyzed. Those were like A1, A2, A3, B1, B2, B3 and C1, C2, C3. You can see this A1 road is like this one, and then A2 road is there, okay, A3 is this one, and then B3, B4. So, they include basically the highway and then the arterial roads and then residential streets. So, all 3 kinds of means narrow, mid and the highway wide and speedy traffic kind of movement were captured. So, the data collection, as I said, it was ground based survey, and data were collected, primary data were collected by using like camera related video capturing, also surveying with the vehicles usage, and stopping requesting people to give some information. So, the data were collected regarding like technology of two-wheeler, three-wheeler, buses and then trucks, heavy vehicle, light duty vehicles, automobiles, all those. So, this was the 6 days survey basically from 7 AM to 9 PM in March to 2003. So, this was the data collection period, and you can see the general characteristics of the cars, two-wheelers, three-wheelers fleet from the survey which was tabulated based on the data. So, like passenger vehicles, so different kind of categories like gasoline 4-stroke with carburetor kind of technology and no catalyst, but then some vehicles will be like gasoline 4-stroke, but carburetor and two-way catalyst. So, if we talk about the percentage or fraction, so the earlier one was 28%, later on 13%, and then you can see this gasoline 4-stroke multi-point fuel injection related technology and two-way catalyst, these were around 22%. So, means population of the vehicle, they were analyzed, the data were collected and their fractions were analyzed. And two-wheeler technology or two-wheel vehicles, so gasoline 2-stroke and 4-stroke, and then their makes when it was made like 1997 to 2001, then post 2001, because the technology also changes, 4-stroke engines, 2-stroke engines, those population were count and the fraction were calculated like 17% of pre 97, okay, 2-stroke, and gasoline similarly like 4-stroke 1997 to 2001, 28% or 28.5, and 23.5% was gasoline 4-stroke two-wheelers post 2001. Okay. Three-wheeled vehicles, so gasoline based or diesel based, all those population were counted. So, diesel based were very less, around 3% or so, mostly gasoline 2-stroke without catalyst were there, 72% around, 22.5 approximately this was 2-stroke, but two-way catalyst. So, different technologies, different category of vehicles and different fuel category like gasoline, diesel, all those kind of things were calculated, so that the estimations of the emissions of different pollutants may be realistic. As good data we can collect, as much category or these minor kind of categories if we can include, then we can have good estimation. But at the same time, if you may recall, if we go for complex data related survey, and then uncertainty also increases. So, we have to strike a balance, and resources are also needed for getting those kind of data. If we talk about characteristics of buses in Pune city, then not only the number of buses, but like Euro 2, Euro 1 or Euro 0 where no those norms were there. So, those kind of fractions and their population were also estimated and collected and then tabulated. Then the driving pattern means how do these different kind of vehicles go with different kind of speeds, like average driving for vehicle type per day, kilometer per day. Okay. So, passenger cars 72,000 population were around 24 kilometer per day, two wheelers population 6,60,000, okay, around 30.5 kilometer per day. So, those kind of data have been calculated, buses 890 and 200 kilometer per day. Similarly, fraction of vehicles and estimated total driving pattern, you can see the fraction and their kilometer per day, the total after multiplying. So, the overall average is this much and the total vehicles are this much. So, the number of vehicles in a region has been estimated by Pune municipal government. So, those data have been taken. So, if there is some uncertainty or gap, that would be there. So, we have to take into account those kind of uncertainties and data gaps also. Well, when we talk about average vehicle speed in Pune city, so like these passenger cars on highways, they are having more speed, these kind of times of the day in early hours of the day, but then this decreases when office hours are there. During office hours you can see these PC, these personal cars in resident areas. So, their speed is increasing, and then two wheelers are also there, which increase basically in office hours. You can see here these are the two wheelers. So, their speed will increase in the office hours in the morning when people are going. So, maybe because number of cars increase, then their speed decreases on the road, and meanwhile two wheeler people can increase their speed and they can take pass and they can go. So, those kind of things are there, and again when road is vacant after like 9 p.m. or so, so then again speed of these passenger cars on the highways increases, right. So, those kind of speed parameters were also noted and considered. If you go for emission inventory using the IVE model, so like CO emissions, if you see these related to startups and the running kind of, means how much CO emissions are there when vehicle is starting, how much it is there when it is running. So, at the start this is this start related estimations and hour of the day, naturally from 7 a.m. to like 9 or 10 p.m. Kind of you can see the time span when most of the activities are there. So, you can see the fraction. Hydrocarbons, basically evaporative hydrocarbons or VOCs are also there from leakage etc. So, that is considered in case of hydrocarbon, otherwise only two categories have been there, like startup and when starting vehicle is starting and when it is running. So, all these CO, NOx and particulate matters, they are only with these two category, like when it is starting, when it is running. But in case of hydrocarbon, the third parameter is also used, which is like evaporative emissions, you can see. But during running, hydrocarbons are a lot of emissions are there of hydrocarbons. Similarly, NOx emissions and particulate matters emissions due to running is more, naturally they have more time span for the running, that may be the reason. But in case of CO, when cold start is there, then unburnt fuel is there, and initially CO is produced more, later on CO2 is produced more. When we talk about like different kind of vehicle categories and their contribution into different pollutants like CO. So, you can see this is two wheelers is the maximum emission of the CO, and their population is also more. Okay. VOCs are also more from two wheelers, and the second is from three wheelers basically. So, the CO, VOC and particulate matter, and also like vehicle kilometer travel, because their number is more. So, naturally their vehicle kilometer traveled is also more. But pollutants perspective, if you see the carbon monoxide, volatile organic compounds and particulate matter, they are more from basically two wheelers and the three wheelers. Okay. When we see about NOx, then situation is different. Here the buses are the real source or dominating source in Pune city, and then this this light duty vehicles are the second, and the two wheelers are also equally responsible, but the majority of the emissions of the NOx are coming from this particular these buses. Okay. You can see. So, buses and light duty four wheelers were responsible for NOx emissions, otherwise other pollutants are coming from two wheelers and three wheelers. Well, now we come to the second case study, which is the application of VAPI model, vehicular air pollution inventory model, and that is applied for estimating like impact of altitude. So, we have considered three cities, Delhi and then Dehradun in Uttarakhand. Okay. This is on higher elevation altitude, and then Mussoorie, which is hill station, you can see. So, those altitudes are quite different. So, we wanted to see what is the impact of those altitude on emissions, right. So, we have seen like criteria pollutants, CO, NOx and hazardous pollutants like butadiene, formaldehyde, so on in these three cities. So, let us see using VAPI model how these estimations are there. Well, there are correction factors which we have taken, which depends on the topography and the geographical location. So, that is temperature, humidity and altitude of Delhi, Dehradun and cities. You can see the variation of temperature here, okay, humidity is here. So, as per the month humidity varies basically. In Mussoorie like July, August, so it is more followed by Dehradun and then Delhi, but in winter time Dehradun has more in January and February or December also, and then second is Delhi, but in Mussoorie it is rather less in comparison to these two cities. So, basically if you see the whole year, different months have different kind of humidity content in the atmosphere of these cities. If you see the CO emissions, so using VAPI model we estimated. So, in Mussoorie CO emissions in different months, you see dominating emissions are in Mussoorie in comparison to other these two cities. So, monthly CO emissions have been estimated and are shown gram per kilometer. Okay. If you see the this vehicle category wise, so these motorcycles 2 stroke and scooters 2 stroke, they are emitting lot of CO emissions, and more in basically Mussoorie and followed by Dehradun and Delhi. So, these kind of variations you can see across the cities in different months as well as across the different vehicular category like moped mopeds are emitting very less CO in all cities, but still in Mussoorie it is more in comparison to Dehradun and Delhi. So, that means CO increases when we go up in the altitude. If you see the NOx emissions, again scooter 4 stroke engines, they are emitting more, and it is more in case of Mussoorie and then moped again they emit very less of NOx emissions. Well, when we consider about like butadiene and formaldehyde, situation changes, like motorcycle 4 stroke, very less formaldehyde, but it is quite high butadiene. Okay, motorcycle 4 stroke. So, if you consider different kind of pollutants, different situation occurs at different places, and in places also, for example, NOx emissions were more in case of Mussoorie, but it is less, this butadiene is less in case of Mussoorie, it is more in case of Delhi, and in between this Dehradun is there. So, when we come down, then butadiene emissions increase, but acetaldehydes again they increase like formaldehyde emissions as you go up. So, those kind of variations you can see. Similarly, estimated CO emissions, if you compare of different months of cars. So, those were those were two wheelers basically. Now, if you compare the cars, then in car also you can see like in Delhi it is more, but in Mussoorie it is less CO emissions. Okay. When we go for different fuel category, so diesel cars are emitting less CO emissions in comparison to LPG. LPG is the highest one. Okay. And in Mussoorie it is more. So, again you can see the difference, and the CNG is again less. So, that means so CNG emissions for CO emissions from CNG car will be less in comparison to this petrol, and diesel will be further less. So, that means the fuel wise variation is also there. Similarly, if we see this emissions from the car of NOx, butadiene etc., different kind of scenario is there. So, diesel cars are emitting lot of formaldehyde, and similarly lot of acetaldehyde and butadiene and NOx. So, diesel car from that perspective, toxic pollutants perspective, it is not good. Okay. And the NOx emissions are less in case of LPG and petrol car rather, and it is also less this acetaldehyde, but butadiene basically CNG car is very good in that sense. So, what kind of pollutants are emitting and which is dominating, those kind of things we can play with the model, and as per the total emissions, if you want to reduce certain pollutant, then we have to see which kind of category of vehicle is emitting more, we have to attack that. Okay, from policy and technology perspective. Similarly, if we want to decide a particular vehicle which is better in higher altitude, then we have to see that which kind of fuel is giving less emissions, so that we should promote those kind of vehicles. So, that way these models really help us deciding better technology, better vehicle which emit less of emissions. Third case study again from VAPI model 1995 to 2005, this period was considered for calculations, and the objective was again to compare these three cities to see the ozone precursors. Ozone precursors are basically like carbon monoxide or oxides of nitrogen, NOx emissions, or VOCs, volatile organic compounds. So, we have to see that temperature monthly average you have already seen for Delhi and those. So, this is the same graph. Then technology description, you can see like fuel related, and then correction factors related to temperature, related to altitude, all these things have been as input parameters basically. So, we see this monthly variation of you can see for Delhi, Dehradun and Mussoorie again CO emissions, and CO emissions you can see highest in June and lowest in January, highest in June and lowest in January in all cities, but basically it is more in case of Mussoorie and less in case of Dehradun and further less in case of Delhi. So, basically these rates depend upon the season as well as on the altitude, and this is related to this light duty commercial vehicles basically. Light duty commercial vehicles. So, these are the variations. So, you can see here this is basically emissions related to light duty commercial vehicle which are driven by gasoline. As you can see in the last slide, this is like petrol, this is the basically gasoline. Okay. And here also the reason is given, higher CO emissions rates during summer months could be due to this high fuel air fuel kind of ratio, those kind of things are there. When we go for basically monthly okay, emission rates of NOx emissions. So, again this is different, means CO was more in case of, like in case of summer it was more and in winter it was less, but in case of this NOx in summer it is less and in winter it is more. So, those kind of variations you can get from pollutant to pollutant. Okay. So, these light duty commercial vehicles, they emit minimum NOx in June and maximum in these January and basically. So, January and December you can see. So, monthly variations can be there again. You can see this VOCs. Okay. So, again VOCs like CO, it is more in case of summer and less in case of winter months. So, basically there are correction factors are also to be applied related to altitude correction, temperature correction, and then total emissions are estimated, and we see that the impact is basically more CO and more VOCs in summer, okay, light duty commercial vehicle based on petrol we are talking, and then less of the NOx, opposite of the NOx. Then if we see these results, so it is also known NOx is less, but emissions of CO and VOCs have increased with the altitude. That was my basically implication when I was talking. So, you can see this CO emission rate has considerably increased from 36.5 gram per kilometer to 51.3 gram per kilometer in Mussoorie, means altitude, higher altitude in comparison to Delhi. And then VOCs increased from 3.2 to 3.6, right, but NOx emissions are less. Okay. So, they were found increasing with the temperature also, like in June it was more. So, with altitude it is increasing, with temperature it is increasing, that is more important thing we have to remember. Similarly, inferences from this VOCs and CO related emissions, because these are the precursors basically. Okay. And NOx emissions are less. So, the VOCs and CO emissions, they can participate in producing the ozone rather than NOx in those particular high altitude cities. So, we have to cater those particular precursors to reduce by some technological intervention. Otherwise, with the in the presence of sunlight in summer, ozone production may be there. Okay. That is very negative impact which can be estimated. When we talk about the fourth case study using VAPI model, then this is related to estimation of exhaust and non-exhaust gaseous plus PM particulate matter and the toxic material or toxic air pollutants from on-road vehicles in case of Delhi. So, this is only focused in Delhi, and the pollutants may be like particulate matter, PM10, CO, NOx, hydrocarbons, greenhouse gas CO2, okay, and then butadiene, acetaldehyde, benzene, formaldehyde, aldehydes, all those total pH. So, all those pollutants have been considered, and the non-exhaust emissions like resuspension of road dust and wear and tear of the tires and brake wear and evaporative emissions. So, non-exhaust emissions have also been estimated. If you see the exhaust emissions of CO2, this is increasing all the over the years 91 to 2020, means 20 years study have been considered, this period have been considered running the model for different years, and we found that CO2 emissions is going on, means even if rather when you go for efficient technology, then naturally CO2 emission will increase. When we talk about NOx emissions, then there is decrease in case of like 2002 when this CNG implementation was there, the whole bus fleet was converted to the CNG. So, this dip was there, but because this number of vehicles were increasing and buses also increased, so the emission again increased because of the population of the vehicles. Similarly, if we see like in case of particulate matter emissions, so there was significant dip in 2002 in comparison to this kind of trend, and then again it increased over the years because the population of vehicles were increasing. In case of like this CO emissions, basically you can see the two dips, one is in 2001 2002, another is 2007 or so. So, the earlier one was related to CNG, but the second dip was related to technology. Okay. So, better technology emissions are there, then naturally CO emissions will go down, because CO2 emissions will increase due to fuel efficiency, okay, in that technology. Similarly, like hydrocarbons, the same thing has happened, as because their emissions have to be reduced, because better burning is there, then combustion is better, then CO2 increases, but other like CO and hydrocarbons decrease in this particular year, and that is related to the CNG. So, you can see like the implementation of a technology can also be captured in the emission inventory based on good models. Well, increase in operative VOCs, okay, you can see the implementation of CNG vehicles was there, and then it also increased. Okay. Then we can see the estimations of non-exhaust road dust and PM10 emissions from the road dust. So, that was estimated as increasing over the years. Similarly, PM10 from brake wears, it also increased, because number of vehicles are increasing. So, naturally it is increasing. If we see this tire wear and from different vehicle category, then cars are more responsible for the PM10, this particular you can see the number, and also this PM 2.5, this predominant source is car tires basically, when we consider these vehicle related non-exhaust emissions. So, tires are responsible for PM10 and PM 2.5. If we consider butadiene, okay, acetaldehyde, then this decrease was there due to implementation of CNG in 2001. Otherwise, the later on, then because of number of sheer population of the vehicles, it increased. If you see the benzene and formaldehyde, these exhaust emissions, then again there is this dip 2 times because of CNG and technology. Otherwise, the increment is there after the number of population of the vehicle increase. Same thing you can see in aldehyde and total PAH, in you can see the increase after the 2001, but technology did not much impact the PAH emissions. Okay. So, this fourth case study related results are basically like private vehicles emissions, like two wheelers and cars, they were estimated to increase from like 2 to 18 times in 2020 over the 1991 level, because of their number increased. Although when you if you discard the population of the people who are shifted towards metro, then it will further increase, but this is basically only the scenario which was responsible for this increase. Two wheelers were dominating emissions of CO, you can see, right, and then private cars are responsible for CO2. So, those kind of category wise domination in different kind of pollutants we can see. Heavy duty commercial vehicles were responsible for more of the NOx emissions, and PM10 were coming basically from exhaust emissions, and then road dust also like 40 to 73%. So, lot of emission sources are there in non exhaust emissions also. Similarly, like tire wear etc., they were also emitting these particulate matters. If we see like IV model, the limitations, that is why we went to VAPI model, because we have seen that in developed countries these models have data intensive kind of characteristics, and rather IV model was designed for developing countries. Still we found that the data complexity and the extensiveness is much more in IV, which in our cities basically is not available that kind of data. So, that is why VAPI was constructed with our group, by our group, but it also has limitations. It is not the perfect model, because there are like speed related correction factors which are not included in this, because we have taken only the vehicle kilometer travelled, we have not seen the variation of the speed, we have taken the only the average speed of a vehicle category. So, means estimations may not be so realistic. If we have the driving cycle and different kind of speeds, then better estimations may be there. So, this is one limitation of the VAPI model. Then we have also seen like it is designed for like 1991 to 2030. So, beyond that there is no scenario creation, we have to alter it otherwise. Only two climatic factors like temperature and humidity and one geographical factor, that is the altitude, these three correction factors have been implemented. Some other models, those complex or sophisticated models, they have more correction factors depending upon technology and other things. Number of vehicle categories in the model, it is restricted in international scope because it is only in Indian context. So, we have taken only those categories which are in India. So, that means if some country like nearby like Bangladesh or so, we can use it, but if you want to use for other developed or middle kind of economies, then it may not be so realistic. So, that is the limitation of the VAPI model, and in conclusion we can say that the application of these models can really help us to generate different kind of scenarios. We can play with them using the emission factors of different fuel or different technology, and then we can apply correction factors of the altitude. So, we can also see the variations in terms of impact of altitude on emissions of different pollutants. So, that way the implications or impacts of the policies or technologies can easily be traced by these models, whether they are effective or not. You have seen, and which kind of vehicle will be better if we are going for like on hilly areas. So, those kind of suggestions can also be made based on these emission inventory development using these models. So, this is all for today, and these are the references which are the basis of this presentation. So, thank you for your kind attention. See you in the next lecture. Thanks again.